Hello and welcome to Decoding MTConnect, automating compliance with transpiled code. This is hosted by True Analytics Manufacturing Solutions, specifically TAMS Connect. My name is Russ Waddell. I'm a board member for the MTConnect Institute and work with True Analytics on the MTConnect Standards Committee, and longtime friend of Trais McAllister, our host today. Trais is a machine tool, machine shop guy turned developer. He's been instrumental in writing a number of open source libraries related to machine tool connectivity. Co-founded TAMS with John Murphy and a few others a couple of years ago. Now they are a shop floor connectivity and reporting platform with all sorts of features that come directly from experience in the shop floor. Both John and Trais are dyed-in-the-wool machinists and shop floor guys. I'm excited to help Trais present this material today. Everything is going to be about MTConnect, but more specifically, it's about, I would say, the biggest hurdle and the biggest challenge that MTConnect's faced over the last 3 to 5 years, related specifically to how do you make things actually work when you start plugging them in on the shop floor. So if you have a nice, beautiful software platform and a bunch of amazing CNC machines, how do you make it so that when you plug the CNC machines into the network and aim an MTConnect agent or aim your enterprise software at those machines, you get what you're expecting? This was, of course, the promise of MTConnect, as well as many other standards for interoperability. Trais will present today some of the ways that has made a lot of progress and some of the ways that that's still a challenge, and how Trais specifically, True Analytics more generally, and MTConnect even more generally than that, are working to address those persistent challenges with shop floor connectivity. Trais, welcome to the webinar. It's great to be here. I hope it's great for you too.
Yeah, thank you very much, Russ. It's a good introduction. So yeah, we'll be discussing essentially the journey that we at True Analytics Manufacturing Solutions has gone through as we've rolled out our machine monitoring and process monitoring software, and kind of the journey of the hurdles that we've encountered with non-compliant implementations of MTConnect, and ultimately how we overcame those hurdles. So to drive this point, we're going to start off with an introduction into MTConnect and what matters to TAMS with regards to MTConnect and our platform and the challenges that we encountered. And then throughout the presentation, we're going to go through each major step in the way to automatically verifying compliancy, and describing the internal process that we at TAMS developed and ultimately made open source. So as Russ mentioned, TAMS started in 2017, rolling out the Revolution Core machine monitoring and process monitoring platform. This is a software system that from the very beginning, we decided we wanted to leverage MTConnect to power this machine monitoring. And one of the big reasons why we did this is because of the semantics and the vocabulary that's defined in that standard. We knew off the bat that this would give us a major advantage when it came to developing the algorithms to calculate key performance indicators like productivity and utilization. And we knew that the time we saved in developing these algorithms would ultimately allow us to expand those analytics and accommodate more of what happens in the real world. Throughout the presentation, we're also going to cover a few additional TAMS products, so keep an eye out for those items, including MTConnect Validator and what we call model-aware MTConnect adapters. Right. So this first section, like I said before, is what matters to TAMS with regards to MTConnect and some of the challenges that we faced getting new machines connected to our Revolution Core platform. So the main driving force for us to utilize MTConnect in the very beginning, like I said, is the semantics and the vocabulary that MTConnect provides. At the time, and still, we consider it to be like the Oxford Dictionary of machine data. Instead of relying on uh, main, like OEMs and manufacturers to tell you what the terms are for this data, you're following a standard set of vocabulary. And like I said before, this ultimately helps us in designing our algorithms. What we're not really going to cover here is necessarily the protocol side of things. There's often confusion when we talk about MTConnect. Uh, it gets kind of muddled with other useful standards like OPC and MQTT, which are more protocol based. We're primarily discussing the semantics and vocabulary uh, when we talk about validation. So the importance of vocabulary to TAMS is, like I said before, we can leverage a controlled set of vocabulary to identify important pieces of information coming from devices and pieces of equipment. So instead of, every time we connect a new piece of equipment, linking that proprietary uh, vocabulary to our algorithms, we can just use a controlled set of terms to quickly and easily leverage that data and inject it into our analytics. Ultimately, the time that we save developing these algorithms this way allows us to spend a lot more time working on real world issues. Uh, there's a lot of nuance in how you calculate things like utilization and especially productivity and efficiency. So we were able to dedicate a lot more time and resources towards fleshing out those nuanced cases in our analytics. So when we, or as we started connecting new instances of our Revolution Core platform, uh, we slowly started identifying, and this is back in 2017, 2018 time period, we noticed a lot of the MTConnect solutions that were out there when we connected it to our platform did not follow the standard as we initially intended. We spent a lot of time reading through the PDF documents of the original MTConnect standards, and we were very familiar with the vocabulary that was used and the structure that was expected. And when we get new machines connected, we found a lot of these implementations were using uncontrolled vocabulary. Uh, they would make use of the extensibility of MTConnect and erroneously extend the standard. So an example of this might be like execution state. Within the standard, we recognize that as execution type data, but some implementations may erroneously name that with like an X prefix and call it controller program or something like that. Um, and so that makes it really difficult for our algorithms to identify that key piece of information coming off the machine and can lead to essentially misinformation on the platform. Now, other examples that we've encountered include, again, uncontrolled vocabulary when you're streaming the data. Maybe they properly named execution, but the values that we're receiving from the machine are not using the controlled vocabulary of active or ready. They're spitting out a numeric value like 1 or 0. Um, and again, this kind of breaks these algorithms, making it difficult to provide accurate information. One of the worst cases that we ever encountered actually was identified in this slide. Every piece of data that streams through the agent should be sequenced with an auto incrementing sequence number. And we've encountered some implementations of MTConnect that the sequence numbers were either duplicated, they were non-incrementing, or they were just missing, which of course is not an MTConnect response. It's just XML. So as we encountered these poor implementations and kind of scratching our heads and trying to resolve issues at our beta customer sites, we started developing the internal process of checking the configurations of these MTConnect implementations, which at the time were all third party. We would check them by hand and just kind of do a spot check to see if there were issues that we had commonly encountered. So the process that we developed was just to simply open up the device configuration file, which is common for a lot of MTConnect agent implementations. And that file is represented as XML, and it's very akin to a probe response. So we would read through this XML, and if you're ever familiar with reading XML, it can be quite tedious. There's an example of it here on the left side. And the process that we went through was really basic. We would identify what version of the MTConnect standard was attempted to be implemented. In this case, in this document, it's version 1.6. So then we would reference the 1.6 version of the standard, which at that time for 1.6 was represented as a set of PDF documents. So we would open up the PDF documents for that version, and we would just go line by line, looking at all of the types of data and determining whether or not those types existed in the standard at that time. And we would just take note of which items we couldn't find in the PDF, which things may have been extended, which things may have been misspelled possibly, and then we would go back to the customer or the vendor of the solution and try to resolve those issues. Ultimately, this process that we developed took a minimum of 30 minutes. Every single time we tried to connect a new piece of equipment, which if you're receiving orders of upwards of 20 machines, you're taking up a couple days worth of time just to validate these configurations. If we really wanted to do a thorough scan of the document, check additional items such as units and kind of verify the IDs of all the data items, making sure that you don't have corrupt data in the future. It took closer to an hour per device. So ultimately, I kind of touched on how this affects the Revolution core, but I wanted to highlight a very specific instance that we had with a customer of ours. And in this situation, there were ultimately kind of 3.5 players in this integration project. We had ourselves, TAMS, we had the customer, and the customer was being guided by a government organization that was providing recommendations for the third body, which would be the MTConnect solutions provider. So this provider in particular had, a box that you would connect to the machine that would then connect to the network and output data via an MTConnect agent. Now, this vendor claimed that they provided MTConnect. Thankfully, we had this process developed and we requested a copy of this device configuration before we got the machine online. Ultimately, when we received that documentation, that device configuration, we spent hours upon hours going back and forth with the vendor saying, hey, we did a spot check here and we found this error, and they would make a change, come back to us, and we'd go through the process again, check it again. And, we found 5 more errors. It was very clear that they were just getting into MTConnect and thought that they could write their own MTConnect agent, very, very quickly and easily. So we ended up spending upwards of 40 hours just purely verifying these device configurations. And by the time we gave the green light to the customer that you can go ahead and connect this equipment to your machine and connect that implementation to our platform. Yeah, it was over 40 hours of just device verification. Um, Unfortunately, some issues fell through the cracks, and we ended up spending an additional, 100 set of hours diagnosing issues that we encountered in our platform. So now we're talking about issues that the customer incurred as a result of this poor implementation of MTConnect. So the analytics ended up being skewed because of this poor implementation, and we had to work with the customer to investigate, what the source of the issue was. Because on the surface, it appears to be an issue with our platform, but we were kind of wise to what the issues might be under the hood, and we had to prove to the customer that this issue actually stems from the MTConnect solution. All of this to say that the customer unfortunately had delays in their integration project. None of us felt comfortable connecting new pieces of equipment, especially with this third-party hardware. And because of the errant data display on our platform, there's immediately a loss of trust on the shop floor, which if you've ever tried to integrate machine monitoring or process monitoring on a shop floor, you know that the culture of uh, getting buy-in on the shop floor is very difficult, and it's very hard to gain trust back when you lose it. Uh, After we diagnosed and found the source of the issue, by that time we already had several months worth of corrupt data that we then, after identifying the issue, had to delete that data. So that was a major blow to the onboarding of this project. That concludes this section. So Russ, I think I'll hand it over to you to see if there's any questions at this point.
There's no questions from the live comments. However, I did circulate this material to a handful of end users prior to the event and have some questions for you, as well as a couple that came to my mind while we were talking here. So I got a few. I'm actually going to work a little bit backwards from the most recent part of the presentation. So one question was, once you'd put in the days of manual validation, the question was kind of what happened next, and were you applying fixes, or was it more simple workarounds? And you addressed a little bit about that at the end.
Mm-hmm. Yeah, so if I understand that correctly, when we went back and forth with the MTConnect solution provider, um, after validating their configurations, yeah, we were providing recommendations to that vendor on, use this terminology instead of that terminology. But we were also kind of assuming a lot of why there were issues with either the configuration or the output, because we also tested the stream response from their agent. We requested them to run a local debug session of that to give us a sample of what the stream's response would be. And we found a number of issues there, which led us to provide recommendations on, this is what the agent buffer is. This is how you're supposed to sequence data. And we did end up working with the developer to improve those over time.
And so just as a clarifying remark here, when you talk about the MTConnect solution provider, the stack up of parties and tools, TAMS has a software tool that you're trying to deploy for shop floor monitoring and analytics. You are consuming data that is, at least conceptually, supposed to be an MTConnect stream off of a machine tool or other shop floor asset. Is that correct?
Correct. Yep.
And the MTConnect data stream from the asset is dependent on an agent of some kind, either the open source C++ agent or a different agent, and it's dependent on an MTConnect adapter, which is taking the native data dictionary of the CNC machine, and it's translating that asset data dictionary to the MTConnect dictionary. Is that correct?
Yeah, in this particular implementation, it was a third party that, yes, they in this case they developed their own agent. They did not use the
Hmm.
reference agent,
Hmm.
uh, and that agent had its own uh, uh, local adapter as well that they developed to convert that proprietary data format from the machine control into quote unquote MTConnect.
Got it. All right. Going backwards a little bit into your presentation, what specifically were you looking for when manually reviewing XML files, the XML, or sorry, the config files? What were you looking for in that XML, and what sort of errors did you actually find?
Yep. So let me go back to this slide here. So this slide are actually a small set of examples of things that we actually encountered, especially in the early days of uh, validating these configuration files. So we encountered a lot of instances where there were extended types defined as data items in the configuration file. So um, lots of vocabulary that legitimately haven't made it into the standard at that point. A lot of the implementations were version 1.3. Other really common examples were you have path feed rate listed as I think a vent when it should have been sample or maybe vice versa. Um, I usually have to look it up in the standard as well, but um, as you're reviewing it, you can see clearly from the standard that path feed rate is in either one category or the other.
So there were a couple other questions, but I'm going to hold off because I think that's a great segue to the next section. This concept that you're describing, where you're manually reviewing XML config files and you are manually referring back and forth between the standard itself and the config file, that's essentially the piece that you are trying to write out of existence and automate with code. So let's move on a little bit to how do we go from this manual review process and what are the next steps to get from there to automating that review and removing the manual steps.
All right. Yeah, so as Russ mentioned, or kind of alluded to, ultimately, internally at TAMS, we had this process now for validating configuration files and the streams, and it just left us really frustrated with, we felt like constantly arguing with uh, MTConnect solutions providers and even with our customers, trying to justify to our customers, what is the actual root cause of some of these issues that they're encountering. So that inspired us to ultimately automate this whole validation process. We were aware at the time that there were some existing libraries for consuming MTConnect within our tech stack, which is primarily C Sharp. Uh, but as you'll see throughout this section, uh, we ultimately decided to move in the direction of developing our own uh, MTConnect C Sharp library from scratch. So why did we create that custom library? We noticed the other implementations for C Sharp libraries, they had very rigid structures, understandably so. MTConnect, is intended to be, very semantics and rigidly based. Obviously, there's exceptions allowing MTConnect to be extended, but those libraries were very rigid and therefore ultimately would not allow us to do the level of validation that we wanted to. We noticed when we used some of those libraries that if the implementation was just egregiously bad, it, like the situation that I just described in the previous section, those implementations would just not uh, they would not be processed correctly, and we would not be able to perform the level of validation that we wanted to. Um, there was also kind of inherent issues with how those models were structured. that would not give us the granularity that we wanted as well, if we were able to provide validation on top of those libraries. Because ultimately we wanted to be able to trace back, to a specific node in the MTConnect response, this node was the cause of the problem. So the initial scope for our custom library, which is MTConnect Core, allows developers to consume responses from an MTConnect agent, such as probe, current, sample requests, even assets. And we also wanted to encourage developers to utilize the interval requests. Um, so we wanted the SDK to kind of facilitate and simplify simply reaching out to an MTConnect agent, getting the response, and then the second point here is being able to convert that response from XML into an object-oriented C# model. And we wanted this model to be flexible enough to accept, the worst of implementations of MTConnect. And then once we had that model defined, we wanted to be able to lay validation methods on top of that, being able to check a lot of the constraints that are defined in the standard, such as the controlled vocabulary. Now, specifically with validation, we also, as a minor point, we wanted to support what we call contextual validation, which is the idea that if you have a 1.3 version implementation of the MTConnect standard, then it's not really appropriate to apply the rules and constraints defined in the current version, 2.4, to that implementation. So if there are things that were deprecated since version 1.3, we didn't find it appropriate that you would say that that's a bad implementation because it was intended to be a 1.3 implementation. So we wanted to add that support as well of contextual validation. So as we developed this this custom library, it ultimately took us about 4 months to develop a working proof of concept library that was capable of doing all these things. Consuming a document, performing basic validation functions, and ultimately spitting out like a report of what validation exceptions were found. We estimated that it was taking about 2 weeks to update this code library anytime there was an update to the standard. And by the time we had this proof of concept that supported up to version 1.6, we were already, I think, about 3 versions behind the latest version of the MTConnect standard. I think 2.0 was just being released. We also noticed that depending on what examples we had of implementations, that there were gaps in some of the validation rules that we originally developed. So certain data items were just simply misspelled in the handwritten code. So I had to go back and fix the spelling mistake. Or maybe I missed when something was removed from the standard, so I had to go and manually add that into the code base. So ultimately, unfortunately, that library was prone to errors, and it still required kind of a human spot check, if you will. So once we had this library fully developed and we were able to produce, like I said, a report of what issues occurred, that report ended up having a huge impact on our customer relations. You can kind of see like a snapshot in the background there of one of the original reports. But what was really impressive is that this code library now performed far more accurate and comprehensive validation because it covered the entire document. And it also checked every single attribute that we at that point supported, which was categories, types, subtypes, units, A lot of the basic enumerations that are applied to data items and observations, but it also was able to create this report in a matter of seconds. I think it took longer to open up the Visual Studio debug session than it did to actually run validation. And by the end of it, you have this nice clean Excel report that you can then, and we did this, is we could then just send that Excel report to the customer, with an email saying, hey, look here on rows, 1, 3, and 15, where we have errors. I recommend changing this or that in your configuration file. So it basically streamlined our whole communication process with our customers when getting new machines online. And ultimately, the customers felt a lot more confident in our implementation. I'll pass it back over to you, Russ, at this point.
Yeah, I have a quick comment on this section. So that when I was my role now often involves recommending or disrecommending certain solutions, and the existence of validation tools has dramatically changed who can actually get a good recommendation to go for an MTConnect based solution, right? So questions I used to ask would be things like, how strong is your shop floor IT, or do you have a developer on staff who also knows the operational technology relatively well? To a large extent, the ability to point to here's the expected output and how does that line up with the actual output from a machine specifically. That's opening up a lot more sort of recommends from me, where I can say you don't really need the same level of eager developer. So it's basically taking, Trais is a gifted developer himself and has shop floor experience, but this encapsulates a lot of his experience and his background into a, at this point, semi-user facing tool. And the more that gets to be a user facing tool, the less critical it is that an individual shop have the same skill set that Trais have in-house, and instead they can basically farm that out or use the tools that are available at their disposal. So that's the reason I'm excited about this, and the reason I've spent time trying to push on this subject a lot. That's it for my soapbox. We did have questions from in the audience. Can you explain the impact of putting data in the wrong category or classifying with the wrong type? For example, why should an implementer know the difference between events and samples?
That's a good question. So I didn't quite touch on this earlier as I was describing the impact on our machine monitoring platform. But another advantage that we found early on when we chose MTConnect to focus on was the categorization of this data. A lot of the attributes that are applied to things like data items and observations also provide a unique opportunity as a developer to sort of componentize, create component structures and reusable visualizations just based on these minute changes in the structure or the semantics of this data. So when we talk about the difference between sample and event, that could be the difference between, are you displaying a heat map for this data, or are you displaying some sort of radial gauge for this information? So it could drastically affect how this data is represented to an end user. There's also other more technical aspects such as efficiency of data storage. Samples are typically stored in I would argue, a more optimized data structure in a database, at least for Revolution Core, than events, just because of the sheer possible scale of data that goes into that data set.
All right, thanks. Next question, how frequently are you running into outdated versions versus up-to-date versions of MTConnect?
All the time. It's 2024, and I don't remember exactly when 1.3 was introduced to the MTConnect standard, but we still encounter 1.3 implementations, either from OEMs or especially third-party vendors. And part of
That's
that,
from the mid. It's from the mid 2010s. It's either 2014 or 15.
mhm, yeah, that sounds about right. And I'm not necessarily against that either. There's a good argument for, you know, letting it be in 1.3. If you have uh, no need to change the vocabulary for that implementation, and that vocabulary that you're using is not deprecated, why change it? I understand that. Uh,
I have a loaded follow-up question.
mhm.
Does anybody know how many outdated versions they're using?
Um, like, are you asking within a
Is
single
there
shop?
any sort so yeah, right. So is there any sort of fleet management practice where, an IT director who's responsible for factory floor assets has an inventory of which agent version or which MTConnect version is on which machines?
Uh, I think that's a good question to open up to the audience, but I know from the aspect of Revolution Core, our platform, yeah, we can immediately query which machines are connected to what version of an agent. And we also have some meta information with regard to adapters if the adapter reports, its compatible version as well.
Got it. Thanks. That's it for questions. So if you want to move on to the next section, we can go ahead.
So the advent of our MTConnect core library and being able to generate this Excel report was fantastic internally. Uh, as I mentioned in the last slide, it was drastically able to improve our communications with our customers on what was wrong with implementations. But uh, as a developer, there was the fear of falling behind the MTConnect standard. I mentioned in an earlier slide that it was taking an estimated 2 weeks to update this code to the latest version of the standard. And I imagine that timeline will just continue to increase uh, as the standard continues to update. So that basically just led to the question of, okay, we automated the validation process, but can we automate the development process as well? Thankfully, at the time, MTConnect was rolling out the implementation of the SysML model. So this provided us with an opportunity that we saw to leverage this SysML model to potentially generate C# code for our MTConnect core library. So this section is going to be describing essentially how we went about leveraging SysML to automate the development of MTConnect core. So as I mentioned, SysML was being introduced into MTConnect. Um, it's currently capable of exporting this entire model into a static representation of the model into XML. So again, we're dealing with XML. Uh, with this complete representation of the MTConnect standard, essentially in an XML file, we said, okay, we should be able to deserialize this XML structure into, again, an object-oriented model. And then the idea was that, with a snapshot of that entire model, we should be able to generate these C# files. So TAMS has collaborated with the MTConnect Institute to develop what is now called the MTConnect Transpiler. And this is a C# library. It's available on GitHub and on NuGet. And yeah, basically it's allowed us to consume the entire MTConnect standard into a C# model. So as you can imagine, if you try to take an entire standard and put it into a text file, a single text file, it's going to be quite large. I think the original PDF documentation for MTConnect totaled close to 700 pages. Um, so this XML file is quite large. It's over 1 million lines long, and it's a very complex structure of sort of foreign relation mapping. So you may have things or entities or classes defined within this XML file in one spot, but things like properties for that class are defined in a completely separate spot. So, for example, if you have a definition of data item and you have inherently properties of when it was introduced, when it was deprecated, even the summary is involved with the data item definition. Those things could all be defined, 16,500 lines below where you initially see it in this XML file. So this presented our first challenge, which was how do we navigate this very complex XML file? So we, within the MTConnect Transpiler project, we prioritized optimizing a series of caches, and then on top of these caches, we provided a static object-oriented structure that allows developers to navigate this complex XML much like you would navigate the table of contents in the PDF documentation. So it's almost like a sort of tree view of accessing packages and enumerations and classes. So with the ability to represent the model from an XML structure into now a C# object-oriented structure, the next step was how do we write these C# files for our validation software? So for this, we utilized a very common C# library called Scriven. It's a template engine that allows us to define a single template file and basically inject information repeatedly into that template to generate a larger set of formatted files. So with this architecture in place, the recommendation moving forward was that anytime you want to create these or transpile the standard into something like C#, you create a console application that essentially orchestrates the deserialization of the model and then the use of something like a template engine to translate that structure into the files. So once we have this solution built, being able to, like I said, consume the SysML model, and now we have the templates designed to generate a mass number of C# files that we normally did by hand. We noticed that the process of designing this transpiler was still extremely convoluted. I'm an advanced user of MTConnect. I know the vocabulary very well, the structure very well, and I even know the structure of the XML file for the SysML output very well. It's still a very daunting task to look at, navigating that XML structure, even with the static structures that we provided originally with the transpiler. So in order to solve this problem, we basically decided to create a transpiler for the transpiler, and we decided to create an additional C# library that you can, again, find on GitHub and on NuGet. We created two. We created one that simplifies the generation of language files using Scriven. We provided a lot of helper methods for navigating and converting elements of the SysML model into other languages such as C#, C++, JSON, you name it. But we also created the third and final project that now serves as a completely hard-coded representation of the MTConnect standard in C#. So we hard-coded all of the references to things like data items and event types device structures and component structures. All of this is now defined and hard-coded in a C# library. And it can be automatically maintained using a transpiler. Again, this is available on GitHub and NuGet. So once we have this solution in place, this hard-coded C# solution, we went back to our transpiler for MTConnect core, and we utilized this new streamlined navigation structure to directly look up, the list of all the different enumerations that we normally did by hand. For example, lists of all the event types and sample types and condition types, all of the subtypes, all the value types, you name it. If it was an enumeration, we use the transpiler now to automatically generate those C# files. So I can actually demo this here. There's a pre-release of version 2.5 of the standard coming out. And what you'll see when I demo this is that we can generate hundreds of files in seconds. All of the code is completely formatted with very detailed summaries taken directly from the standard. And we're also able to flag when things were introduced and deprecated in the model. Ultimately, we call this, our model-aware solution. So Russ, if you can confirm, you can see Visual Studio.
Yep, that looks good.
Okay. So what I have here is our MTConnect core library in Visual Studio. And if you're familiar with C#, great. Yeah, this makes sense to you. If not, don't worry, because all we're going to do is just run this transpiler project, which is a console program. And anyone should be able to see here that I have essentially a configuration saying that I have a reference to that systeml model. It's just an XML file. So this is the static copy of the version 2.5 of the MTConnect standard. And I've told this program that I want you to spit out all of the transpiled code into this directory, which in this case is the directory in the MTConnect core project. It is this folder right here. So I can automate the development of all of these files that you see here with a click of a button. So when I run this, it opens up this terminal program, and the transpilation is done. So it processed 96 different data item types and subtypes and 37 value types and created C# enum files automatically. And if you're familiar with Visual Studio, you'll notice this little red indicator indicates that the file is changed. And if I investigate this file further, you can see here, again, for people familiar with C# or some programming experience, should be familiar with code summaries. So all of these summaries are completely taken directly from the MTConnect standard. I don't have to maintain it. I have references to when, in this case, acceleration subtypes was introduced into the standard, version 1.0, and also a link to where that's defined in the standard documentation. So I can open that up and I get sent directly to the model browser. Other examples include support for deprecations. In this case, we have the code event type that was deprecated in version 1.1. And there's flags introduced into this source code automatically. If I look at GitHub desktop, this was a completely fresh branch. And after running the transpiler, you can see there's just a ton of files that were changed. In this case, a lot of the changes were simply an update from version 2.4 to 2.5, but you'll see that some items were actually just introduced in version 2.5. So this is a kind of a sneak preview into what's coming in MTConnect. The particle count has been added. Here's that. I think we're at a point, Russ, that I can pass it back to you.
All right, you have a bunch of questions about SysML and about code gen, so strap in. The first one's the easiest one. From the comments, why did MTConnect choose SysML? What or who drove that decision? I can answer that for you in a succinct manner. In 2020, at version 1.8, subsequent to 1.8, the chief architect, Will Sobel, and his assistant architect, Sharab Singh, who were working full-time on information modeling for the spec, they found SysML and UML as tools to do information modeling and thought that it may be applicable to MTConnect. They proposed to the MTConnect Standards Committee a move away from paper-based documentation towards modeling language based. They started with UML, talked to a couple of end users at large enterprise manufacturers who had systems modeling and system building experience, who recommended SysML over UML for a variety of technical reasons. That was then put before a vote based on the proposed change from the architects, and the committee approved that. And for version 2.0, the major switch was from paper-based to model-based in SysML. Did I miss anything on that answer, Trey?
No, that was very succinct.
Okay, so the next questions are about code gen. There are some in the comments, and I also, coincidentally enough, a couple of hours ago was on a call with a information modeler who works for a manufacturing company and was sort of bemoaning is maybe too strong a word, but pointed out the limitations of directly writing code from a SysML or UML model. It seems to me like you basically have the answer here, which is yes, code gen is relatively complex and new out of SysML. However, SysML provides useful prerequisites to getting to code gen. I'm not sure what the question here is, so maybe just speak about SysML and code gen a little bit.
Yeah, so SysML, at least in terms of the MTConnect standard, um, the way that we've been able to leverage that has not been through, uh, I guess, SysML directly. For example, we're not interfacing with a SysML modeler like Cameo. We're leveraging the output of that SysML model into the representation of XML, which we can then programmatically work with. So that, yeah, I mean, when we initially scoped this out, we found that to be a limitation. There's kind of, it seems like an ever evolving methodology for, uh, how that SysML structure can be represented. Even as we've rolled out the MTConnect transpiler, which does uh, convert that XML into an object-oriented structure, uh, we've noticed we've had to make significant changes along the way as the SysML model is updated in order to accommodate that change in the structure. But that's still far better than having to maintain all of the vocabulary, in my opinion.
Yeah, so then a related question, are there other examples of similar utilization of SysML by other or related standards?
I am not aware of that, but I'm not aware of examples, um, and that's mostly just because I don't know that I'm in the right circles to be on the up and up. But I do foresee this architecture being heavily utilized by other standards, and actually that kind of segues into the next section a little bit.
Yeah, and I would also point out that the systems modeler who was commenting this morning on code generation and limitations, I think it's significant to point out that this person didn't work at the manufacturing company less than a year ago, and they didn't replace somebody else who was another modeler. The company brought in a systems architect who has systems modeling experience in software specifically for a manufacturing enterprise, which tells me a lot about kind of future direction.
Agreed, and I think this this whole exercise with MTConnect is, I think, is going to prove as a good stepping stone for other standards to get on board.
Just to directly answer the question about known examples, the Dimensional Metrology Standards Consortium, which is the organization behind the Quality Information Framework, the QIF spec, they have made significant motions towards a model-based approach. We're still debating between SysML and UML, and the last I checked, some of that decision was a little bit hung up on funding. So there's definitely a first-time expense in how to set up the modeling environment and find the person and tools to make that happen. And then there's also an ongoing maintenance requirement that it's not unique from having an information architect of some kind, but it does mean that there's a specific set of maintenance requirements that have to be met. So DMSC has talked about it a lot. That's not particularly new news, and there's still not a SysML model or UML model completed for DMSC and QIF, but that's been talked about extensively, and as far as I know, is still in the works. And with that, Trey, let's move on to the next section.
All right. All right. So this next section is kind of a continuation of what we realized after developing the MTConnect transpiler and kind of leveraging that in a couple different projects. We soon found that this sort of architecture just makes sense if you're going to work with MTConnect or anything that is model based. It makes sense to start off with something like a transpiler if you want it to be compliant with that standard. So quickly after identifying that we've kind of fallen into this trap that we keep developing solutions this way internally at TAMS, we decided to kind of brand this this architecture as what we call model aware. So this section is going to be about kind of explaining what model aware is and ultimately what we find the advantages to be of that architecture. So model aware is essentially an architecture that leverages a program that can transpile the standard from its original format, in this case SysML, into another format. It just so happens that for us, that other format is consistently C#. So when we talk about transpiled code, in this case the C# code, this is always automatically generated from the standard, and we can say that it's essentially derived from the standard. What we like about this approach is that it references the source material, the standard directly. So there's very little human interfacing that can potentially screw it up. I mentioned very early on when we developed MTConnect Core that I'm human. I had spelling mistakes in transferring the controlled vocabulary into code, and I imagine this is a very common issue. And then the efficiency side of things, bar none, having a program write program is far more efficient use of my time than writing it all by hand. I would much rather spend a few seconds running a program than 4 months developing a handwritten copy paste from a PDF document. So, and ultimately, this model aware architecture concept does not just apply to MTConnect. As that previous question kind of alluded to, this architecture can be applied to anything that is model based, not even necessarily SysML, although SysML has obviously been proven out through collaboration with the MTConnect Institute. So just continuing the advantages here that we mentioned, yeah, the maintainability of our code now, aside from being able to generate it to begin with, is far simpler. You saw in the demo here just a couple of minutes ago that I had a fresh branch for our MTConnect core library, and I was able to just click a button, and now it's completely up to date with version 2.5 of the MTConnect standard. Um, Again, going back to reliability of the source code, I've eliminated the issue of quote unquote fat fingering uh, names and values that are normally present with handwriting code. And I say all this ultimately to funnel down to the fact that this is a very cost-effective architecture uh, that ultimately I spent far less time developing the transpiler solution than I did handwriting the original MTConnect core library. So if I were to kind of take those same hours and apply it to a product or solution, I could have introduced far more feature rich and better user experiences and user interfaces to my products instead of copying information from a standard. So throughout the presentation, we've kind of touched on a couple different TAMS products, but I wanted to highlight just how far-reaching this model-aware architecture has been integrated with TAMS products. So MTConnect Core, again, is one of our open source libraries, allowing you to consume MTConnect responses, and we were able to apply model-aware to maintain essentially all of the validation across the standard. Our Revolution Core monitoring and process monitoring platform leverages this validation inherently, and we're also able to pass through the definitions of glossary term like vocabulary and terms and put that directly in the user interface. So we can kind of educate users on MTConnect terms native in our solution. This model-aware approach also inspired us to just go ahead and start developing our own MTConnect compliant adapters. So we have what we call model-aware adapters, and we developed a whole new transpiler solution that's actually far more expansive than the MTConnect core library that covers device structures and component structures, as well as supports definitions of all the data items. So this open source library also allows you to essentially develop an MTConnect adapter using an object-oriented approach to modeling your device. And then finally, we have a complete overhaul of our original MTConnect validation software. We migrated from a console application into a very feature-rich validation suite, which I can showcase next. But I think we'll take another pause here for a second, see if there's any additional questions before we move on.
So this is my favorite question, and this came in before the stream started. What model other than an MTConnect model, what other models can the model-aware approach consume? And I think more importantly, what kind of modeling are you running into at customers? Do they have models? What do they look like? Do they know they have models? Are they in line with this, or is this something that you're pushing?
Yeah, so the models at this point, we've just focused on MTConnect, so dealing with the SysML model available through MTConnect. In order to achieve this, that's where we developed the specific MTConnect transpiler project. Now, theoretically, a lot of the code for that open source library could be reused for any other SysML model. It's pretty flexible, but at this point, we haven't received a use case to attempt consuming any other model.
Got it, and that somewhat answers the second half of the question. Everybody has a data model; they just might not know it. It may be an ad hoc model that just came from what their table structure looked like, which is not a great model, but it exists, whether you call it that or not. That was it for this section. So I think we have one more section to go.
Yeah, one more section, and then we'll open it up to just kind of general Q&A. All right, so now we're going to highlight kind of the final phase of our validation journey. I mentioned in the very beginning, this has been ultimately a journey not of Transpiler, but of introducing validation into our processes, validation of MTConnect implementations. So this section we're going to highlight, ultimately what we've been able to achieve in providing validation. So where we started was MTConnect Core, just a simple console application capable of spitting out an Excel report. And with this new model-aware architecture that we introduced, we said, okay, I think now is the time that we can upgrade this console application into a fully, feature-rich web application. So we developed this web application. We now provide it online at validator.tamsconnect.com, and we can provide far more visualization tools and analysis tools into your MTConnect implementations. The very first thing we focused on was looking at the Excel report. We saw some room for improvement in how we styled it and how we formatted it. So we added, simply being able to filter to find specific severity levels of exceptions. We encountered some response documents that were about 10,000 lines long. So we desperately wanted to improve that to just focus on errors. That was the first thing that we did. Oh. All right, there we go. The second and probably the largest improvement to date to our visualization process was introducing visualization of the XML itself. So the web application now simplifies the distinction between validation errors and warnings using color coding. You can see here on the left side, we have, red equals bad, error, yellow equals warning, yellow. We also made this interactive. So as an advanced user, I find it still very helpful to be able to look at the XML in raw format. So we made this sort of two-panel visualization that still lets you look at the raw XML. But we couldn't stop there. We saved so much time maintaining the solution, might as well spend some of that time to make life easier. So we introduced kind of a Microsoft Office style, squiggly lines under the nodes. So you can see here in the very bottom for header, you got red squigglies because there's an error. In the case that you have very large XML files, we also added the feature to be able to click on individual exceptions, and it jumps you into that spot of the XML to review it further. The next kind of minor update that we did, because we had the data, we had the ability to create links directly to the MTConnect Institute's model browser. So for some parts of the XML visualization, you can actually double click on parts of that document, and it will jump you to the appropriate area of this model browser. So you can reference the MTConnect standard directly if you have any questions. Because we save so much time, we also said, hey, there's a popular request out there for years now of being able to just simply validate if my device configuration is going to be compatible for a specific use case. Let's say I have a piece of software that tracks all of my furnaces. I want to be able to make sure that an MTConnect solution for furnaces has all the right data item outputs to work with this software. So this tool basically can be used as a spot check to see if your implementation has all the right data items. The final feature we wanted to highlight, and one of the newest ones that we've added, is visualizing the device configuration for an MTConnect agent. So again, a quote-unquote devices XML is a very common approach to configuring an MTConnect agent. We see that in the reference agent, and I've also seen it in a lot of OEM and third-party implementations. So as a way to visualize that and kind of highlight possible non-compliance issues, we created this visualizer that creates this hierarchy diagram and literally highlights in red or yellow which of these items are non-compliant. And you can click on those items and review what things were wrong. So this is just an alternative approach to the previous visualizer that you saw. And that is it for the updates on the visualizer. Again, just want to highlight some of the products that TAMS offers that have been affected by this whole new model-aware architecture. And we'll open it up to further questions.
There's no questions from the floor at this time, but I want to point out that although I don't have any commercial relationship with TAMS now or in the past, I do want to know, Trais, how do you use it? How do you get it? How do you buy it? What's free? Talk me through the buying process for anybody that's ready to deploy this stuff right now.
Yep. So you can review our full product offerings on tamsconnect.com, as well as here on LinkedIn. We've listed all of our products available here on LinkedIn through this link. So you can use any of the Contact Us Now buttons and links to reach out to sales or to myself or John directly. We can set up a demo, or you can just say, hey, this looks great, I want it.
Thanks, Trais. Next question from the comments. Have you had customers who are successfully using the tool to perform multiple upgrades to MTConnect with adapter agent or machine tool provider upgrades? And that's coming from somebody, an end user.
I'm sorry, I got a little bit lost the wording on that. Can you?
Yeah, sorry. Let's see. Have you TAMS had customers use this tool to do upgrades to existing MTConnect implementations in their facility?
Not yet. We have a couple customers that are looking to leverage this online validator and use that as a way to justify upgrading implementations. But other than that, internally at TAMS, because we offer this machine monitoring and process monitoring platform, we also use it as a way to kind of spot check and make sure that we have coverage for the data that our customers want.
Okay, next question, and I also share this question. Can you, Trais, share a couple comments about the transpiler, specifically with respect to DevOps or DevOps in an industrial environment?
That's a pretty broad question, but yeah, I mean, I think right now the workflow that we have introduced is simply create a console project in your solution to implement the transpiler in the way that you need, because each bit of source code is going to need to be formatted differently to suit your solution. And right now, our workflow is to just simply run that manually, because it literally takes maybe a total of a minute to create a new branch, run the transpiler, and then create a pull request. There has been some work done internally at TAMS to start developing tools through like GitHub Actions to automate this process, so that theoretically you could trigger a pipeline automatically in DevOps. Whenever the MTConnect standard is updated, run this pipeline to run the transpiler, create a pull request, and then wait for it to be approved.
Follow up to that. I may be asking the wrong person, but are you seeing Are you seeing interest in those sort of industrial CI/CD pipelines or something like that coming from your customers, or is that something that you as a developer and TAMS as a software company are having to push?
Yeah, so this whole effort has purely been kind of built off of necessity. That's kind of our motto here at TAMS. We developed machine monitoring because we felt that the tools weren't being the tools that we wanted to see were not being developed. And similarly, uh, we encountered we identified an issue with our processes. We said, hey, let's fix it. So I think we're at the point now that we've matured it at least internally, and we're ready to kind of open it up to the public and see what else we can do to improve it.
Yeah, certainly the in the early days of MTConnect back in the late 2000s through the mid 2010s, the idea of DevOps for the factory more or less didn't exist. The talk of the town was, can we get open source tools? And the deployment and maintenance of those tools was something of an afterthought at the time. Not that nobody was thinking about it, but it was, we'll get to that once we get over the first hurdle of actually having some widely used open source libraries and things like that. And I think that the tide has shifted pretty significantly on that. There have been large companies who've dramatically expanded their IT infrastructure and staffing to bring sort of mainstream practices to industrial environments. And we're starting to see that trickle down and drip over into even small and medium machine shops and discrete manufacturers who may otherwise not have been directly looking at those, and particularly as they start to engage with, cloud providers who have other customers who are looking at that sort of a pipeline, and the architecture for something like your cloud services is essentially built with the assumption of those large-scale pipelines in place. I see a lot of information cross-pollination happening, particularly over the last 2 years. So it's exciting times, and I see this as a pretty fundamental tool. Trey, that's it for questions that I had from before, as well as from the floor. So I'll let you wrap it up with final comments.
Yeah, and thank you all for joining. It's been great to kind of walk you through the process that we went through and identifying a problem with validation, and ultimately how we went about solving that problem. And I think the solution that we came up with by introducing, the model-aware architecture is definitely something to keep an eye on in the future. Something that I think could be applied across a variety of standards related to manufacturing. Ultimately, my belief is that this could certainly have a good impact on a lot of the kind of future thoughts for smart manufacturing.
And with that, thanks everyone for joining us. I appreciate you taking the time, and we look forward to seeing you next time. Thanks.
Thank you, Russ.